Hello friends, hope you all are doing good. In today's video, we are going to discuss about the Snowflake storage layer. How data sits in this storage layer. Yeah, we will discuss about the micro partitions. We will discuss about the continuous data protection life cycle or the CDP which Snowflake provides for protecting our data. We are going to discuss about the clustering, why clustering is required, what is the benefit of clustering. With that, we are also going to discuss best practices around all those topics. Got it? So, we will go very deep dive into each part of all the topics which are mentioned here. We will go very deep dive, how micro partitions are created, what is the size, what happen if you update one some records, what happen if you drop some tables, right? What happen if you delete records? So what will be the impact on micro partitions, right? So very deep dive we are going to go today in each of these topics, and you are not going to get in-depth knowledge about all these topics in any of the YouTube video. Got it? So after this session, you people are going to have a very good understanding of how micro partitions are created, what are the properties of micro partition, what is clustering, why clustering is required, when we are doing clustering, what is the impact on cost, what is the impact on storage, right? So also, we are going to discuss about the continuous data protection. What are the features which Snowflake provide to protect your data? In case mistakenly you deleted some data, you dropped your table, what is the continuous data protection, features which Snowflake provide. And with that features, those features comes with some cost also. So what are the best practices, how we can minimize those costs when we have enabled, auto clustering on our tables, right? Or when, we are deleting lot of records. So what happen inside, so basically we are going to discuss very deep dive. And this session will be a mix. It will be a whiteboard session. Plus I will be showing example on Excel also. Okay, guys. So let's start. So, guys, what is storage layer, right? I think we all knows this is the three-tier architecture of Snowflake, right? On top, we have this cloud service layer. Then we have this, yeah, storage layer. Sorry, this is the compute. This is the compute layer, right? Or virtual warehouse. Virtual warehouse or compute. And now at bottom we have this storage layer. Got it? This is the storage layer. Now, as a user, we have control here. We can create virtual warehouses. We can resume them. We can suspend them. We can resize them, right? So all those operations we can do it, right? But for cloud services, as a user, we don't have access, and here also we don't have access. So basically, as a user, we don't do any activity or planning, right? These are created by its own when you create your Snowflake account. Same for this storage layer also, right? We don't do any planning, capacity planning, right? We don't do any capacity planning also. We don't create this storage account also. So basically cloud service layer and storage layer, these two layers or these two components get automatically created when we create storage account. Okay, so this is the brain, and this is a very important component of Snowflake. It does lot of operations. So whatever data is sitting here, This cloud service is having all the information, in which micro partition data is sitting, what is the size of micro partition. Got it? So all the information is sitting with this cloud service layer. So basically this cloud service layer is having all the metadata, all the metadata. It have information or metadata information about your virtual warehouses also. It have all the information or all the metadata, information about your storage layer also. Which table maps to which micro partition, and which micro partition contains which data. Got it? So all the information is there with cloud services. So basically cloud service is the decision maker. This is a brain, this is a control plane, okay, which drive your virtual warehouse or compute part also, and it drives your storage, part also. So today we are going to discuss, or we will be mostly around our storage layer only. Now, in storage layer. So in storage layer, how my data is saved, or I will just put storage only. So first you people have to understand this storage is your cloud storage. Got it? Since Snowflake is a SaaS service on all the cloud provider or on the hyperscaler, so when you create a storage account, you select whether you are going to create this on AWS or Azure or GCP. So this is something you people will decide. And on the basis of that, if it's a AWS, your cloud storage or cloud layer internally, it will be your S3. If it is a Azure, it will be your blob storage, and this will be your cloud storage, right? Got it? Now, how data is saved internally? So basically, in storage layer, your data is saved in micro partitions. I'll just put MP, micro partitions. Okay, micro partition. Now let's take our old days. In the old days, when I create any big table, let's say this is my table. This is my table, some table in, let's say, in Oracle or somewhere, let's say SQL Server or wherever it is, right? SQL Server. So my data sits here in rows. Got it? This will be my rows. Let's say this is having a 12-month data. This is having a 12-month data starting with Jan till December 25. When I do select star from this table, where let's say ID equal to something. Got it? So in that scenario, I need to scan all the rows, right? All the rows. Now, this is going to take a lot of time. Let's say in a 1 year, my table size is, let's say, 60 GB, which means for ID equal to 1, I need to scan all this 60 GB data. Got it? Even though we have a concept of indexes also, which will fine tune your query, but just think of in a very simple way. Now these databases also, they come up with the partition feature, right? Partition feature, where we need to define upfront that on which column and what will be my partition strategy. Whether I am going to do it monthly, weekly, so that is up to us. So basically, first what we have to do, we have to define the column upfront or decide the column upfront, that on which column I need to create a partition on this table, and then I need to define the partition strategy, whether it will be monthly or weekly as per your application, right? So let's say now it's monthly. So let's say on this table TBL1, I said do a partition on this table on a monthly basis. So let's say this is my one partition for Jan. This is the second partition for Feb, and so on. Let's say this is the partition of December 25. So two challenges. One is I need to define this upfront. Got it? Now let's say for Feb, I got a let's say 10 GB of data, which means in this Feb I am having a 10 GB of data, and rest 50 GB is divided among rest 11 partitions. Got it? Which means your data is not uniformly divided among the partitions because of this logic, because I am telling divide partition this table on monthly basis. Got it? Which means if I am scanning any data which is sitting in this Feb month, I have to scan 10 GB of data. Got it? Or in other sense, we can say data is not uniformly distributed. So this is where now Snowflake come up with the idea of micro-partition. So when we say micro-partition, so basically micro-partitions are continuous units of data. Got it? Micro-partitions are uncompressed. They are uncompressed and data saved within micro-partition. So data saved in micro-partition is in columnar format. Got it? And this data will be compressed. The size of micro-partition starts with 50 MB and it goes up to 500 MB. And these micro-partitions are immutable, which means once created, you cannot modify them, cannot change them. Got it? So basically, these are the properties of micro-partitions. All these properties. Now, this size, okay, who decide this size? This 50 MB or 500 MB is totally a Snowflake decision. Okay, Snowflake decision. Who decide this size? We don't have control. As I said, in storage layer, we cannot log in. We don't have access. We even cannot check how my files are sitting there. Got it? How my files look like. Can I delete some files? Can I access them? No, we don't have access to all. And the data, all the files, okay, are saved in FDN format, which is a Snowflake proprietary format. Got it? This is a Snowflake proprietary format, FDN. Got it? So basically, these micro partitions, you can think of these are small files. Got it? Small files having a size of minimum 50 MB goes up to 500 MB. Got it? Let's say I'm having a 10,000 MB of data inserting into Snowflake. When you start inserting this, so Snowflake will calculate, okay, I'm having 1,000 MB, so best approach will be what I can do. I can create 200 micro partitions, each of each of 500 MB. Got it? Got it? Let's say this much size, 10,000 MB. Okay? Let's say I'm getting a 10,000 MB of data getting inserted into Snowflake. So Snowflake will decide what will be the ideal size, whether it should be 500 MB or should I start with 50 MB or 60 MB. Got it? But do you think if Snowflake start with 50 MB, how many micro partitions will be there? Lot many. Lot many partitions. Got it? Probably 2000 micro partitions. Got it? Probably if Snowflake decides I'll go with 50 MB, then for this 10,000, for this size, this size, this much size, file size, if 50 MB Snowflake decide, it is going to have almost 2000 micro partitions. Got it? Which will be very, very huge, and maintaining this 10,000 this 2000 micro partitions will be a overhead for Snowflake. And why? We will come to know. Got it? So this is how basically Snowflake decide whether this 50 MB or 60 MB or 500 MB will be the right size or not. So this is totally a Snowflake decision. Got it? So once data is sits in micro partition, that micro partition will never get changed. So let's have a look with the Excel and with some data. Okay guys, so let's consider this is my file having a employee information. Got it? And we need to insert this employee file having 3 columns: ID, age, and name. This can be your CSV file, it can be your any format file you can consider. Okay, and this file can be at your own premise in some NAS location. It can be at your some cloud storage location owned by you and your application separately outside this Snowflake account, right? And you need to insert this application, let's say, into the TBL underscore employee table. Got it? And this employee table you have created at your Snowflake account. Got it? Now, so this is your table. So when you are inserting this data into this employee table, which is sitting at Snowflake, your data will be divided or saved into micro partition, as I said, right? So let's say in our case, since this is a very small data, it can fit into even single micro partitions also, just in KBs. But let's consider Snowflake has created 2 micro partition. One is MP1 with size 50 MB and another is MP2 with size again 50 MB. So both are 50 MB, 2 micro partitions. Got it? Now what we said, that whenever data is getting inserted into micro partition, it will be saved into columnar format. First thing. So now you can see for this ID. So let's say first records, I got 2 is here, 6 is here, 7 is here, which means all the ID column data is sitting together in a columnar format, right? This is age, these are the names. Got it? Now other records after 11 from here, afterwards this row, these records 20 till let's say 32 are sitting here. So just for now, just I will remove this one. Just this is not required. So remaining records from here till here, they are sitting in this micro partition. Got it? So this is how basically your micro partitions are getting created and the data inside this micro partition will sit in columnar format, and this will be the compressed. This all the data will get compressed here. Got it? So two micro partition, MP1, MP2, each of 50 MB, and data will saved in a columnar format, right? So now you can see this ID column having all the rows together. Here also this is the ID column in MP2. Age column records are sitting together. Names columns are sitting together, right? Got it? So let's say if I says select star from this TBL employee where ID or select, select star from TBL, select IDs or I would say select ID from TBL employee. So what Snowflake will do? It will give all these records from here, from these two micro partitions, right? Just two columns. So that is the benefit of saving data in columnar format, because in columnar format is best for your analytical queries. See, because in analytical queries, basically what we do, yeah, out of many column, we will be doing a aggregation group by or selecting some limited columns, because all the columns are not useful in your warehouse or analytical workloads, right? There are some business values, or some calculative columns, are some columns are there which are having a some value on which we are doing a some group by having, and all those aggregations to get the best of from that data which business can use for doing the analysis and analytics and predict the market. So that is the reason columnar format is very best for your use cases, where or very good for warehouse and analytical purpose. So first thing, micro partitions, 50 MB till 500 MB, data will sit in columnar format and it will be compressed. So within this 50 MB, so see, this is your micro partition. This is your micro partition, this whole micro partition inside which is uncompressed. But the data which is sitting inside this data, see this data, this will be compressed, and this will be saved in a columnar format. Got it? So micro partition is clear. Got it? Now let's consider. Now we will come to immutable. What is the meaning of immutable? Immutable means, let's say I changed this record. I say this record I have changed, and I have changed this record also. I said update this TBL employee. Got it? I said that update. We said update TBL underscore employee. TBL employee set age equal to 24, where ID equal to, let's say, got it? It's one only, right? Or two. Let's say it's two. Now what will happen? Now see the concept of immutable. Now what Snowflake will do? For now, let's ignore this one. Yeah, I updated this record. Now all the information that in MP1 where this 2 is sitting, it is sitting in MP2, MP1. So all this information will be there with cloud services. When you run this query, update TBL employee set age is equal to 24 where ID equal to 1. First, this will go to cloud service. Cloud service will get the information on which micro partition this ID is equal to 2 is sitting. So it will instruct, okay, ID equal to 2. Okay, it will say your ID equal to 2 is there in your, got it? So it will say that cloud service will say that ID equal to 2 is there in micro partition MP1. Got it? At this storage unit. It will give full address. Okay. Now what Snowflake will do? it will mark this whole micro partition as to be deleted. Now just think, that's just very important, very important. The concept, I just updated this record, id equal to 2, make this age as, make the age as, 24. Earlier it was 23, make it as 24, or let it be 23. Okay, we are changing this. Got it? For this id is equal to 2 and this is his name. Got it? Basically, for this id is equal to 2, update this age to 24. Now, as I said, we have seen the property of micro-partition is micro-partitions are immutable. When the micro-partition reaches the minimum size of 50 MB, it will be marked as immutable. Immutable. Got it? It will be immutable, which means I will just copy this one. What Snowflake will do, it will create up one more micro-partition. This will be your MP3. Got it? For this id is equal to 2, I am updating this 24. Got it? Now this will look like this. Got it? Like this. And this whole will get marked as, let's say, to be deleted. To be deleted. Now what will happen once to be deleted is there? We will just come to know in some moment. Got it? Now when this is done, now see, for this id2, this is the age which we have updated, right? So this is the previous version. Got it? Got it? Now let's say you says mistakenly I have done. But mistakenly I have done, you want to revert it back. So from where Snowflake will revert? Still this data is there. It is not going to be deleted. I am telling this is not going to be deleted. It will go to CDP cycle. We will come to know. Okay. You want to roll back it? It will get rolled back. It will take value from here because still this micro partition is there. But this is not active. Now active one is this one. So active is, this is active and this micro partition is active. And this micro partition is marked as to be deleted. Once marked as to be deleted, see, it will still be in the storage account. Got it? Now cloud service layer. So now this cloud service layer will be having a 3 information for this table. So what cloud service will have? So cloud service will be updated that for TBL underscore employee table, the active micro partitions are MP2 and MP3. These two are active. And this is the MP1 is marked as to be deleted. Got it? But we will be charged for all these 3 micro partitions. This is 50 MB. This is 50 MB. This is also 50 MB. So we will be, even though my active are these two, these are active, this is active, this is active. But we will be charged for this micro partitions also, this is also, this also. Got it? Now we have seen Continuous, we have seen this micro partition, uncompressed also, we have seen columnar format also, uncompressed also, 50 MB also, immutable also, right? We have seen everything. Now, what happened? Now, first understand the CDP, continuous data protection of Snowflake. Got it. So what is this feature? So in this feature, basically we have two things. One is time travel and another is fail safe. Got it. This will be maximum up to 7 days. This will be maximum up to 90 days. Got it. Here up until you have data in time travel. Until you have data in time travel, user by own can recover from here. Got it? Recover from here. But once it go to fail safe, users or Snowflake account owner cannot recover. We have to take a help of Snowflake team. Got it. So how this work? You have this. We had this micro partition one. I updated some record here, right? Snowflake created MP3. Got it? This is marked as to be deleted. As soon as this is marked as to be deleted, it goes to time travel. It will not get immediately deleted. Time travel. And let's say you configured, let's say 20 days, it will be in time travel phase for 20 days. Maximum will be 90 days by default. Got it? Now let's say this 20 days or this 90 days is over. It will move mandatory to fail safe. And it will be there in this phase for maximum 7 days. And after that, data will be permanently deleted from Snowflake. Got it? From Snowflake. This is your CDP cycle. This is your CDP cycle. So basically, as soon as your micro partition is marked as to be deleted, it will go to time travel, maximum up to 90 days. Once this window is over, this will go to fail safe phase for maximum 7 days. After this is over, then data will get permanently deleted from Snowflake account. Okay. Now, since we are covering this time travel and all fail safe, so basically, if you see, we have your temporary tables. We have permanent tables and we have transient table. Got it? Yeah. For this temporary table, there is no fail safe. No fail safe. And they are session specific. And I think time travel is also maximum. Time travel is also, I think, maximum 1 day. If you have not deleted this temporary table. Permanent table goes through 90 days time travel plus 7 days failsafe. Transient tables are not session specific, but so basically this transient table is having a both the properties. Got it? Transient table is having a both the properties. So what I said, so transient tables are having a both the properties of permanent table and temporary table, which means the transient table are not session specific, means they persist outside sessions, not session specific, plus so this is your permanent table property, plus they will not have any fail safe feature, no fail safe, plus time travel also I think 1 day. Got it? So this is your temporary table property. So guys, this is very important. Very important. If you are having a tables, if you are having a some permanent tables which are having a very frequent DMLs, try to convert them to transient tables. Got it? Because with each DML, you will be having a micro partitions created. Got it? If your data is not that important, if your data is not that important and you don't need a CDP as such, then best is go to transient tables, because here you will not be charged for time travel plus your failsafe. Got it? Yeah. So best is go to transient table in this case, because your failsafe is not there and time travel is also maximum to 1 day, 0 to 1 days. Got it? So this is the CDP continuous data protection feature which Snowflake provides. So basically two things as a part of CDP, it provides time travel and your failsafe. So coming to this example again, now as soon as this data is marked as to be deleted, so this will go into the phase of time travel. This whole will go to time travel first. Got it? And it will be charged. So whatever storage this micro partition is consuming, it will be charged. Then so this will go to time travel first. After this is done, then this will go to your failsafe. And for failsafe also, for all the duration for failsafe, you will be charged for storage consumption also. So basically, unless your failsafe window is over, after that only your micro partition will get permanently deleted, and you will be stop charging for that micro partition, and unless that you will be charged. Got it? So we have seen temporary tables also, permanent tables also, plus we have seen transient table also. So, temporary table, session specific. Let's say I created some session to, I have created some session to Snowflake system. Got it? Or basically the use of, this session table. So let's say I have a reporting system, right? I have some reporting system. I'm a user of that reporting system, and I connect it to Snowflake system. And I have some input parameter. Let's say from my reporting system, I have some input parameter. I pass those input parameter, and on the basis of those input parameter, intermediately I need to do some, calculations. So the best thing will be what I will do. I will create the temporary table as a part of session, and I will insert data from Snowflake into that temporary table. I will pass my input values which I have uh, like ingested from my reporting, and I will do all the calculations intermediately from the data inside the temporary table, and then I will create my aggregated data from that data, and after that I will drop that temporary table. The other user, if other user also opens same report and he is also using a same report, and passing he's also passing some different values. So अरे सुनो, हेलो, अरे सुनो. So if other user also accessing the same reporting portal, right, and uh, he's also using same report which other user was using. So whatever calculation the first user was doing, he will not be able to see that. No, for him the calculations will be different if he's passing different parameter. Got it? So these temporary tables are very, very session specific. They will be just visible to the session. Okay, one session. It will not be visible to the other session. Okay. The transient tables are kind of a permanent table, but there is no fail safe. They will not go to fail safe life cycle. The maximum time travel they can go for is 1 day. Whereas permanent table, they will go for a time travel maximum 90 days or whatever you have configured. Plus, they will go for a mandatory fail safe of 7 days. Got it. So basically, this time travel and failsafe are meant for user if for getting recovering or rollback your data. Okay, up to previous state. Got it. So let's say now it's let's say now timing is consider any time. It's 6 p.m. Let's say. Got it. And you want to revert back your table data to let's say 5 p.m. 10 minutes, so you can do that using the time travel functionality, because your data is not removed totally from your Snowflake. It is still there in time travel, so you can still recover from there. Got it? So that is the benefit of time travel. Even let's say after 90 days also you want to see, okay, 3 months back I want to see, or I want to do some testing. You got some compliance requirement where you need to you need to send some data, or you need to check some data which was there 3 months back. Got it? So for that scenario your data will still be there in fail safe, but maximum 7 days. For that you need to take a help from Snowflake. As a user you will not have access using queries and all. You will go to Snowflake and then you will tell, okay, I need my data before 90 days, and this was the time or day, but just think maximum 7 days. So basically 97 days, 90 plus 7 days. So basically till 97 days you can get your data. So 90 days, up to 90 days, it's in your hand. Anytime you can run the query and you can get your data. But for next 7 days, you need to take help from Snowflake. Got it. So micro partitions we have seen, transient tables we have seen. Now clustering. What is the use of clustering, guys? Can you see here how data is sitting? This is not clustered, right? My 20 is here, then 3 is here, and 41 is here, and 31 is here. Okay. See, one more important thing which I forget to mention here, your data in micro partition is distributed uniformly. Got it? distributed uniformly. Now you can see, right? Almost, you know, some it's in uniform, right? My IDs are here also IDs are there, age, name, right? So basically among two micro partitions, my data is uniformly distributed. But let's say I ran a query, I says that select star from TBL employee, order by age. Good. Or let's don't do age, let's say order by ID. Now what will happen when I say order by ID? Now my this data is, it will read this partition. Got it? Put it into memory. It will read this partition. Put it. So basically first it will read all this partition. Put into memory because it's select star. It will read all this partition. Put into memory. Then do order by. Then combine both the result and send it back to user. Right? Got it? Even though Snowflake does a clustering. So what is clustering? Clustering is you are ordering your order. Ordering, store your data in some order, right? Even though naturally Snowflake does clustering, it put a data in some specific order, in a natural order. The way in the sequence you are getting, inserting your data, so in that order it does a clustering. That is known as natural clustering. It is efficient but not great when you are having a queries where you are doing a order by, got it? Group by. See, in group by also what happens when you do group by. So internally your data will get first in a order and then internally you do a aggregation, right? Group by. Randomly you can do a group by, right? So the internal logic of group by is when you say group by, first database will do the ordering of your order in ascending order and then it will do the that group by on top of that. So for all the queries where you have analytical workload, you are doing group by, order by. If your data is clustered, if your data is ordered in ascending order or descending order, whatever you want, the queries perform very well. Got it? Now see, this is the example of clustering. Now let's say I said. So okay, now let's say, got it. For now you can just ignore this one. We can ignore this one. Now same data, this same data is coming. Got it? Now same data is coming here. But now on this table I said cluster key as ID. Got it? And also I have enabled automatic clustering. Got it? See. Now on this table, I have defined cluster key on ID column and I have enabled automatic cluster. Now see how my data is, even though I am getting data in this form. Just see, very important. I am getting data randomly. Got it? My data will be saved in a ordered way. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all in a ordered way. Got it? See here. It's a ordered way. So whenever I do a select star from table or select age, select age from this table where Yeah, I will just simple say, let's start from table order by, ID. So my data is already sorted. This is the benefit of clustering. Now what this, see, when you mention this clustering cluster key, so basically you define that to you tell to Snowflake in which order or on which column, on which column value your data has to be ordered and saved. Got it? Now we are having and now let's say we are having so many DMLs. Inserts are happening, DMLs are happening. Got it? And so what Snowflake will do, even though it will try to fit your data in a clustered way, in a ordered way. Got it? In a very ordered way. Okay, now let's say, okay, now consider this is the my first day data. Got it? Now this is my first day data. First day. Now again on second day, I got same records, same this data. Again, I got it. Now what will happen? This is my first day data. Snowflake created 2 micro partitions. Now, as I said, these partitions are immutable. So now Snowflake decided the maximum partition will be 50 MB. Next day, again I got same record, similar records. Means on next day, on second day, again MP3, MP4 will be created. And data will sit in a similar way. Got it? See, data will be much, in a real scenario, it will be, much more different and much more sensible. But here I am just telling you with the conceptual perspective. So don't go with the data, just go with the concepts. Okay. Now we will see how automatic clustering will done. Now I have MP1, MP2, MP3 and MP4, 4 partitions. But if you see my ID is 1 here also, my ID is 1 here also, right? Now let's say again third day. Again third day I got your similar data, which means on third day also my my micro partitions will get created. Got it? How many micro partitions? Again 2. Yeah. So let's say again now this is done. This is done. Got it? MP5, MP6. Got it? But can you see this MP1 is here also? One is, let me mark, one is here also, one is here also, one is here also, one is here also. Okay. Okay. Yeah. One is here, 3 places. But ideally it has to be, this one ideally has to be sitting in same micro partitions, right? Because now I have clustered my table on column ID. With this automatic clustering, guys, very important. Very, very important. With this automatic clustering, so this automatic clustering will run your cloud service with the serverless feature will run automatic clustering process in middle. Okay. It will reorganize all these micro partitions. Guys, very important thing. Very, very important. It will reorganize all these micro partitions. It will mark all these micro partitions as to be deleted. Got it? To be deleted. And it will create new micro partitions with the data. Just listen. With the data, something like this means it will reorganize. Your one will sit here. Got it? This one will come here from here. Okay. This one will come here. Got it? Okay, just 1 second. 1, 2. Yeah, this was 2. This 1 will come here, 2 will go here, this 2 will come here. Got it? So basically, it will try to reorganize all this data so that your data will come in a ordered way. Now, this 1, 2, 3, 4, 5, 6 micro partitions will go into time travel and then to fail safe. And now this will be your active micro partition. All this will be your active micro partitions. Got it? This will be your active micro partition. So basically, Snowflake will do all the reorganizations. 1, 1, 2, 2, let's say 3 will sit here, this 3 will sit here. Got it? Now this will also get updated, this will also get updated. Got it? So it will reorganize all this data in a ordered way. Now, what two things? When we are doing auto clustering, it is adding cost to your storage. Plus, there is a serverless service which is running in behind and reorganizing this data, which means with this cloud service, so when automatic clustering is running, storage grow serverless features. Okay, serverless. Behind the scenes, serverless service will run for reorganizing all this data, right? Plus, cloud service will get updated with the new metadata. Got it? With the new metadata. Now, so that is the reason we says whenever we are having automatic clustering, we have to have to be very careful, because we will be charged for storage which is getting grow, plus we are charging for serverless service also, plus cloud service also will add something to cost. Yes. Now let's say we have a concept of clone table also, right? Clone table. So guys, I'm just extending one more topic since we are touching this micro partition, time travel, fail safe. So let me touch this clone table also. So clone table, got it. Now let's consider, let's go to example here again. Now this is my, let's say, I'll just do Control Z. Okay. You will just got it. Now this is my data. I'll just remove this color. And I will remove this unnecessary micro partitions just because these are not required. We already seen the concept of reclustering and all. Just consider this one. Yeah. Now this is TBL employee. Got it. Now let's say I says I need to as a user. So basically we have two users. Let's say we have user 1, user 2. Both wants to work on this TBL employee table. He is also updating some records for his test cases. He or she also updating records for his test cases. But if both use same table, right, data will be inconsistent, because he will update some records, he will also update some record, he will also insert some record, he will also insert some record, he will do some deletion, he will also do some deletion. So both are going to impact their each other data. So best is, so in normal scenario, what you will do, you will create a one copy of this table, correct? Copy of this table, and you will tell, okay, this copy of this copy underscore table is the copy of this employee table. You can use this, and and user 2 can use this table, right? So both can do testing. But the problem is, let's say this is 10 GB, this is also 10 GB, which means 20 GB storage I am consuming. But that is not the case of Snowflake. In Snowflake, there is a concept of clone table, which means for this TBL underscore employee, I will clone one table, clone underscore table. Got it? And this is clone. When I make clone underscore table, which is a cloned copy of this employee table, which means both this table and this table are referring to same micro partitions. This data, both tables are referring to this micro partitions. Got it? Even though table names are different, but they will be referring to MP1 and MP2, and cloud service layer will be having this information. And no storage charge, no extra storage, because we are referring to same micro partitions. Now let's say this clone table inserted, let's say 20K records. Got it? Now what will happen? In that case, cloud service will create one new micro partition, new MP mapped to only this clone table, which means here one more micro partition I'm just creating here, simple, just for understanding. One more micro partition will get created, new underscore MP. Got it? New underscore MP, but for clone table. Got it? Clone table. So this is clone table. This micro partition is for clone table. Got it? Now let's say TBL underscore employee. So I'll just put it as yellow, some color. Got it? This I'll put it as green because this is with both the tables. Got it? This is with both the tables. This is referred by both the tables. Got it? This is my clone table. Now let's say this TBL underscore employee, in TBL employee also user 1 or user 2, we assigned this to user 2. So user 2 also inserted some records, which means Snowflake will create one more micro partition. Got it? One more micro partition. Got it? It will create one more micro partition. This one, this micro partition. This. Now let's say this I will mark as some different color, some blue one. Now this micro partition will be referred to your, now this is MP, let's say 4 micro partition for TBL underscore employee. Got it? Table. So now these two micro partitions are referred by both the tables. This micro partition is referred by only clone table, and this micro partition is referred by only table underscore employee. Got it? Now the ownership of this MP1 and MP2 relies with the TBL employee because he is the original owner. Got it? Now let's say I dropped this table, employee table. I dropped this employee table. Let's say now the situation is now how many micro partitions are there? MP1, mp2 new underscore mp mp4. Who is the owner? Owner is tbl underscore employee. Who is the owner? tbl underscore employee. Who is the owner? Clone underscore table. Got it? But this micro partition is referred by this also. Sorry, our clone underscore table also. Got it? Now let's say I drop this table. Now just take a moment and think what will happen. Will it go to time travel and then fail safe and then removed all data? No, nothing will happen. Even though this will be marked as to be deleted, even this will not be marked as to be deleted. As soon as you drop this table, the ownership will be mapped to clone table because clone table is still referring this. Got it? Clone table is still referring this. Got it? So once you drop this table also, now all these micro partitions mp1, mp2, new mp, mp4. Okay, important thing. As soon as you drop this table, this drop table, so these ownership of mp1 and mp2 will move to clone table, and this mp4 will mark as to be delete, and it will go to time travel, then fail safe. Because this mp4 is not referenced by your clone table. This is not referenced by clone table. Because when we cloned this TBL employee, only that time mp1 and mp2 were there. Got it? So clone table will be referring only to the data which is there in mp1 and mp2, not to the data which is there in mp4. So as soon as you delete TBL employee, this mp will go to time travel, fail safe, and eventually will be removed from Snowflake account. But ownership of this will transfer to clone table. Got it? So once you drop this clone table, then all these micro partitions mp1, mp2, and new mp will go to your time travel, fail safe, and eventually your whole data will get removed. Got it, guys? So guys, this is about today session. Hope you have liked this session. You were able to get a lot of information about the how clustering works, the how clustering add goes to the storage. Got it? How micro partitions work, the size, they are immutable, how they are immutable, what happens when you delete data, what happens when you drop tables. We have read about transient tables also, we have read about temporary tables also, permanent tables also, we have read about time travel also, we have read about failsafe also. So guys, apart from that, if if you look more deep dive in any of this specific topic, you can please comment me. I will definitely come up with that topic also. And thanks for watching this video.